W is xy over z, xz over y, z over y, and then x is s times e to the t, y is s squared plus 2t, and z is 4s minus t. Under these conditions, the question is find round w over of round s. Find the partial derivative of w with respect to s, and evaluate that partial derivative at st equal to, the question is 1, 0, but let's try something else. Let's try 2, 0. Let's try to evaluate that. All right, and obviously there should be some conditions added to this. You have to use the chain rule and all that. So here's a question about using the chain rule. So z is a function of s and t, so are x and y. And w is a function of x, y, and z. So if you change the value of s, it's going to change these values, and it's going to change w. Now from here, the first thing that you want to do is to be able to draw the dependence diagram. Let's try to see how it's done. First, let's try to convert this to dependence diagram. W depends on x, y, and z. How do you write that down? W depends on
X, Y, Z.
x, y, z. And then x depends on what? S and t. So you put s and t, you make x, draw a path from x and s. So x depends on s and t. How about y? Y is also depending on s and t, so put this. And then what? How about z? It also depends on s and t. It depends on all of those variables, and that's it. That's the dependence diagram. Now from this dependence diagram, now we can write down the chain rule. Okay, can you see the 3 paths going from s to w? This, right? So let's write down the chain rule for each individual paths. WXS. So you write down round W, round X, round X, round S. WYS. So that must be round W, round Y, round Y. WZS. So round W, round Z, times round Z, and round S. Now we have to compute each of these partial derivatives, and then after computing it, our final goal is to evaluate it at 2, 0. Yes?
What about Z?
It's only asking you for how W is changing with respect to S. I mean, I could also ask round W, round T.
So it could be round W over, would it ever be round W over round S and round T?
I can do second partials, but that would be too much. I could, so things, you can think of many different things like round squared W, round S, round T. That would be a second derivative, but that would be too much of a lot of computation for that. So I'm not going to do that. I mean, what's possible is maybe I could put a third variable here, put it as u, and ask dw du. So that could also be something. But the necessary technique that you really need to know is to be able to first figure out all the paths from one variable to the other. So So you call this the independent variable. These are dependent variables, right? So from the independent variable to the dependent variable, and once you figure out all the paths, you have to convert it to a chain rule. Okay? All right, and then round W, round X is, let's see, what do you get if you differentiate this by X?
C over Y.
Z over Y, because if you differentiate X, just 1, right? Z over Y. And then round X, round S. If you differentiate this by S, well, you differentiate S, it's just 1, so it's just e to t. Okay, now let's think about round W, round Y. And it's a little more complicated than before because Y is in the denominator. So let's think about this. If you have 1 over Y, and you differentiate it, what do you get? Negative 1 over Y squared. People said ln, you're remembering the integral of 1 over Y. If you integrate 1 over Y, it will be ln of Y. If you differentiate it, it's this. Okay. So please remember this. Using that, you can write it as negative xz over y squared times, what's the UIDS? If you differentiate this by s, 2t is considered as a constant, so it goes away. And if you differentiate by s, 2s. Okay, now round W, round Z. If you differentiate W by Z, you get Z differentiates to 1, so it's just x over y. And then finally, if you differentiate Z by S, you get 4. Okay, so that's the derivative. That's the derivative of W with respect to S. And then we still have to evaluate it. Let's try to evaluate ST as 2, 0. On the review sheet, I have it as 1, 0, but I want to try this one too. 1, 0 didn't seem that interesting. So let's try 2, 0. Okay, if you have 2, 0, let's think about the value of x, y, and z. X would be, if s is 2 and t is 0, this will be just 2. And then if, for y, if s is 2 and t is 0, that will be 4. And for z, 4 times s, that's 8 minus 0, so it's just 8. Okay, so evaluating this derivative at 2, 0 for s equal to 2 and y, t equal to 0, not only means that s is 2 and t is 0, but it has implications for x, y, and z, because x, y, and z also depend on s and t. And you have to plug these in. Yes?
What does y say up there? S to the what plus 2t?
S squared plus 2t. S squared plus 2t. So 2 squared is 4. Okay. So therefore, if we compute round W round S at S comma T equal to 2, 0, this is what I'm getting. Z over Y is 8 over 4 times e to the 0th power. So now all you have to do is just plug in all these values. Every time you see some variable here, go back and see what those are. S is 2, T is 0, X is 2, Y is 4, Z is 8. You just plug them in, okay? Plus, negative, X is 2, Z is 4, no, Z is 8. Z is 8, Y is 4. And then times 2 times 2 plus x over 4. X is 2, y is 4 times 4. 4 cancels. These also cancel. That's 2. So it's 2 minus 16 plus 2, which is negative 4.
Professor?
Did I make a mistake?
Yeah, I think so. It's 2 times 8 over 4 squared.
Oh, 4 squared. Thank you. So this will be 4. Oh, that'll be 0 again.
Yes.
Okay. So I think, okay, I see.
Absolutely.
Yeah, if I evaluate 0, it always gives.
Or one in the car.
Okay, but anyways, this is how you compute such a thing. Do you have a question? Yes.
So what is it y squared? Like negative xz y squared?
Yeah, it's y squared here because if you differentiate 1 over y, it's negative 1 over y squared.
So would it be 4 squared?
It'll be 4 squared, and one of the 4's
Oh,
canceled, and there was this 4.
Okay.
And 2 times 8 is 16, 16 divided by 4 is 4.
Thank you.
That's here. Any other questions?